All right, we're going to be talking about angles. All right, everybody look at 151. Page 151, follow along with me in your textbook, okay? Angles are formed by two rays that share a common endpoint. All right, so we know that a ray, of course, here you have these. A ray has an endpoint on one end, and they go here. They meet at a common endpoint right here, which is also called the vertex. Okay, so this is a ray, and this is a ray. Okay, and they go endlessly in this direction, but they end right here at the vertex. Okay. All right, so this is an angle essentially. All right, you should be taking notes as we go through this some, okay? Or at least highlighting in your book, and I'll allow that as well, okay? Now, the rays of the side, the rays, speaking of R-A-Y-S, of the sides of the angle and the common endpoint is the vertex. But the size of the angle, which is measured in degrees, is determined by the amount of rotation between the sides, which involves using a protractor, which we will get to tomorrow, okay? So I have protractors here that we'll use in the classroom. Any of those students that are home need to have their own at home to use. Hey, let's look at the table at the bottom of page 151, all right? Now, we're going to talk about an acute angle. And if you guys remember last year, I said an acute angle is so cute. I said that an acute angle is so cute because it's tiny. But an acute angle, it measures what? Well, look in the book. It measures anywhere from 0 degrees to 90 degrees. Okay? Which is somewhere along this line here. That's an acute angle. Okay? In other words, it's less than 90 degrees. Okay? Which is a right angle. Correct? Let's talk about a right angle.
Never a left angle.
Never a left angle. That's right, Noah. I'll never forget that. All right, so here we have a right angle.
It's like an L shape.
Yes, there you go. Now, I'm going to put my arrows here, okay? And one identifying key to a right angle is that a square there in the corner. You guys see that? Yeah. I'm going to color that yellow.
Joanna's favorite color is yellow.
Okay? So that's indicating to you that this is a 90 degree angle. And exact. It's exact. No wavering. Okay? It's an exact 90 degree angle. If it would be 91, then it would be an obtuse angle. If it would be 89, then it would be an acute angle. Okay? That is a right angle. Remember, you have a square here in the corner at the vertex that indicates that it is an exact right angle. That's important to know. Of course, then we have an obtuse angle.
It's a big one.
It is a big one. All right. So let me draw another line or two here.
It's a triangle.
Okay. So we know that I did learn how to draw straight lines. It's definitely not by my doing, but anyway. All right, so we know that this is larger than a 90 degree angle, right?
Yes.
Okay, so an obtuse angle is anywhere between 90, actually it's 91 to 180 degrees or 80. Let's just put more than 90 degrees. I think your textbook says 90 to 180, but technically I don't agree with that because an exact 90 degree angle is a right angle. So I would technically say it would be between 89 and 179 because an exact 180-degree angle is a straight. Okay, so anything that measures more than 90 degrees is an obtuse angle. It's obtuse. Okay, angle. Okay, it just goes straight. Okay. Now, again, this is 180 degrees, and this is a straight angle. Okay, that's another angle that we'll be looking at. Okay, now one that we haven't learned about in the past is a reflex angle. It's sort of an upside down obtuse angle in my opinion, but it measures anywhere between 180 and 360 degrees. Let me show you an idea of what okay, so you have your end point here and your lines going that way. Of course, if this line here, if this line here was more straight, which is really how it should be, and then so you go from here over to here, then you have more than 180 degrees. So it's 180 degrees to 360 degrees. That's what a reflex angle is.
That would be hard if I was like a...
Now, let's talk pairs of angles. Okay, we're going to go through at least page 152 today, and then tomorrow we'll pick up on those things. All right, so we're going to be, let me write this here. We're going to be talking about an adjacent, vertical. We're going to be talking about a complementary. I think we talked about this last year. And then we talked about a supplementary. Okay, so let's start with, okay, so adjacent angle. So anytime you would have an angle like that, well, that's not the angle, that's just a line. Bear with me and I'll get it going here.
I accidentally put panes of angles.
Okay.
I need to fix that. I thought that was an N. I put
Of course, we want our, we know that these are actually rays that are connected together. So what are adjacent angles? Look in your textbook with me, highlight that. Two angles that share a common side between them and a common vertex are adjacent angles. Okay, so there's an angle here and an angle here. They share a common vertex and side, so that is considered an adjacent angle. Okay, now let's talk about a vertical angle. Okay, and a vertical angle goes something like this, and okay, let me do the talking, okay? All right, so a vertical angle. When two lines intersect, right there's your intersection, okay? When two lines intersect, they form two pairs of opposite angles called vertical angles, okay? So these two are vertical angles, pair of vertical angles, and this is a pair of vertical angles, okay? In other words, angle 1 is equal to angle 2. Angle 3 is equal to angle 4, okay? So when those intersect, the angles across from each other, not beside each other, but across from each other, equal. Does that make sense? Yeah. All right. Now, complementary angles we talked about last year. Okay, complementary angles involve right angles, okay? You can complement someone 90 times, right? Because it's a right angle. And then you're going to have another angle coming out here. Okay? Now, here we have angle 1, angle 2. It's referring to the angles here. Notice you have your square that indicates that is a 90-degree angle. Okay? So if you add angle 1 and angle 2, you're going to get 90 degrees. Okay? So that tells you that angle 1 plus angle 2 equals 90 degrees. That makes sense? We talked about this last year. Now, a supplementary angle is dealing with 180 degrees. All right, so if we have okay, so an angle from here to here measures how many degrees? 180. Okay, that's that's what a supplementary angle equals 180 degrees. Okay, now I'm going to erase this 180 right here because I want to show you something. So what it's saying, this is angle 1 and this is angle 2. And again, it's saying that angle 1 plus angle 2 equals 180. Because this is a 180 degree angle. Okay, that's half of a circle. If it would go all the way around, it would be 360 degrees. Okay? Now, let's, yes. So now, look with me at 4.4. All right, so if you are looking for complementary, remember complementary angles equal how much?
90 degrees.
Equals 90 degrees, okay? Supplementary angles equals how much? Supplementary equals 180. Make sure you put that degrees mark there, okay? Now, let's just say that I know that angle X I know that angle X equals 75 degrees. But I want to find out what the other angle measures. How would I do that? Well, if I know that it's a complementary angle and it measures 90 degrees, then I'm going to take 90 degrees and I'm going to subtract what I know, which is 75. In other words, if you had this.
75 from 90 degrees outside would feel good.
So let's say this is 75 degrees. This is a right angle, and I know this is a right angle, and I don't know what this is going to be, and that's what I'm trying to find. So 90 minus 75 is what? 15, right? So that tells me that this angle answers my question, that this angle measures 15 and that angle measures 75. Okay? That represents a complementary angle. Now let's look at a supplementary angle, which we know equals 180, right? Okay, now, got a little happy with that one, didn't I?
Yes, you did.
And let's just say that we know that one of them measures about 75 degrees. Okay? So, all right, so we know that this whole angle from here all the way over here equals 180 degrees. But we are given this measurement, which is 75 degrees, right? But we don't know what the measurement of that angle is. But we can find that without using our protractor by saying 180 minus 75 is what? 105.
It was actually 180 degrees outside.
So this is 105 degrees. Okay, does that make sense?
Mm-hmm.